Hi guys, Dr. Musk back again, and we're continuing our discussion of the biochemistry chapters in Chem 131 with chapter 20, which is carbohydrates. So carbohydrates are also commonly referred to as sugars, and then complex carbohydrates, polysaccharides, are often called starches as well. So the general trend for the reactivity of those is they have lots and lots of hydroxyl or alcohol functional groups and some kind of an aldehyde or a ketone in them someplace. All right. The simplest ones of those are monosaccharides, where we only have one of those polyalcoholated carbon-based things instead of stringing two or more of them together. So we can link multiple saccharides together, multiple carbohydrates together, and we'll see what that looks like when we get to things like disaccharides and then things like cellulose, which is a polysaccharide. So the most common of the monosaccharides that I want you guys to know about I shouldn't have circled, so I'm kind of undoing what I just did. Glucose and fructose, both 6 carbons long. The difference being that glucose has an aldehyde functional group, whereas fructose is a ketone functional group. Now, we didn't talk about the stereochemistry of these yet. Not that important for us to worry about, but at each one of these carbons where there are 4 different things attached, we call those things stereocenters. And the fact that each one of those can be different, you can see for the first stereocenter in glucose, the hydroxyl group is on the right, and in the second, it's on the left. So what does that mean? That means that those 2 stereocenters will look opposite from one another in space. And this Fisher projection is a simple way for us to keep track of those stereocenters. You don't have to know all about those because we have de-emphasized stereochemistry in the course, but if you count, we can see that there are a total of 4 of those stereocenters in glucose, all right? And then in fructose, I see only 1, 2, 3 of those stereocenters. So here's a disaccharide. When we put 2 monosaccharides together, and those are normally linked through some sort of a hemiacetal or an acetal linkage. So that happens to be an acetal linkage because you can see that that carbon here, well, the arrow's already there. The carbon there is bound to 2 oxygens that are not OH groups, but instead it looks like a diether, all off of 1 carbon. We call that an acetal functional group. Very common way to join monosaccharides together to make a disaccharide. And then polysaccharides, even bigger, all right? You can see here that we have starch, which is one kind of polysaccharide. There are bunches of them. So 3 or more monosaccharides together makes a polysaccharide. Carbohydrates are made through photosynthesis. It's a way that energy is stored through reduction of CO2, all right? And we eat them and use them for high energy tasks. Generally, the form that we use in our bloodstream is glucose, the first monosaccharide that we looked at together. So that is a very common circulating energy source in our blood. So monosaccharides normally have 3 to 6 carbon atoms. There are some that are longer than 6, and they have an aldehyde or ketone and lots of OH groups on them. All right. Now, very importantly, you should know what we call monosaccharides that have an aldehyde functional group. We call those aldoses, and monosaccharides with a ketone functional group are ketoses. All right. You sometimes call them aldose sugars or ketose sugars, depending on whether they contain an aldehyde or a ketone functional group. Here are a couple of 3-carbon monosaccharides, glyceraldehyde, and you can see glyceraldehyde does have one of those stereocenters, whereas dihydroxyacetone does not have a stereocenter. It does not have any carbon with 4 different things bound to it. All right. So note that glyceraldehyde is the smallest aldose sugar that exists, whereas dihydroxyacetone is the smallest ketose sugar that exists. They both have the chemical formula C3H6O3, which means they're constitutional isomers of one another. Remember that definition? Back in chapter 11, we talked about that. Two compounds that have the same chemical formula but different order of attachment of atoms. All right, so you can see in this case they have different functional groups even though they have the same chemical formula. You don't have to memorize all these names for what we call different types of monosaccharides with 3, 4, 5, or 6 carbons in them, because we do a lot more to look at the hexose sugars, the ones with 6 carbons, than any other size. All right. So monosaccharides like glucose and fructose taste sweet. Depending on which one you're talking about, that can vary quite a bit. Fructose is one of the more sweet tasting monosaccharides. As we might expect, because there are so many OH groups on them, they're super at hydrogen bonding, they're very polar, they dissolve well in water, they have high melting points because they're super duper able to hydrogen bond. So we don't have to talk all about what a Fisher projection looks like, but if we want to think about in 3 dimensions what one of those, well, the author here calls them chirality centers. A lot of people call them stereo centers or chiral centers. Basically, what we're talking about is how those 4 groups attached to that carbon with the arrow to it, how they're oriented in space. And remember, we use wedges and dashes to look at that. So you can see that these 2 stereo isomers of one another, and they're mirror images, so we call them enantiomers, they're actually mirror images of one another. So the stereo center or chirality center is opposite in the 2 of them. All right. You will not have to do anything with stereochemistry other than perhaps look at one of these pictures and tell me how many of these stereo centers, these chirality centers, you see in a monosaccharide, something like that. So it turns out that we use this nomenclature of D or L to talk about the 2 possible mirror image forms of different monosaccharides, and it depends on whether the OH is on the right or the left at the farthest hydroxyl group or at the farthest chiral center from the aldehyde or ketone. That's what tells us whether it's D or L. You will not be tested over that. You will have to remember that naturally occurring sugars are the D stereoisomer. All right. So D-glucose is the natural form, and L-glucose, there aren't many organisms that can even metabolize that because our enzymes are built to look and to metabolize D sugar specifically. You don't have to memorize anything about this slide at all, other than that glucose is the most common sugar that is regulated in terms of what we call blood sugar. All right. So circulating glucose allows our muscles to have energy. Here are some other common monosaccharides. Now, if you look at the difference between glucose and something like galactose, the only difference they have is at that 3rd chiral center down. They're very, very similar to one another. So monosaccharides that differ only at 1 chiral center from one another, those are often referred to as a pair of epimers. I don't think I'm going to test you guys over that, but pairs of epimers tend to be structurally similar enough that those sugars could be used for very similar jobs to one another. All right. The enzymes that work on glucose also to some extent will probably work on galactose because of that structural similarity. Notice that fructose is quite a bit different because, remember, it's a ketose sugar instead of an aldose sugar like glucose and galactose. We don't need to talk about diseases where we can't metabolize sugars. Beta-galactosemia is one of those diseases. So I do want you to remember that fructose and glucose are hexoses, 6-carbon sugars, but you can count that yourself. Now, that's probably enough of an introduction for us to the monosaccharides. more than anything, I want you to become familiar with those terms aldose and ketose, and then also to remember that the natural stereoisomer of sugars is the D stereoisomer, not the L. All right. Thank you guys for paying attention. This